السلام عليكم ورحمة الله وبركاته. أهلا بكم في SPE Basra Student Chapter. وياكم الطالب رضوان جاسم حسن، طالب في جامعة البصرة كلية الهندسة، وعضو أيضا في SPE Student Chapter. اليوم محاضرتنا اللي هو البارت 2 من Production Logging Tool، مقدمة من قبل الأستاذ محمد الإسماعيل. نبذة مختصرة عن الأستاذ محمد الإسماعيل. هو مهندس بتروليوم في جامعة البصرة، خريج سنة 2018. عنده خبرة بالبرودكشن and well integrity في SLP more than 7 years of experience. Certified trainer with 10 courses and 15 workshops delivered locally and abroad. Speaker at SPE University and Gothic at 2025 with NODIC. Introduced the stethoscope tool in Iraq to enhance efficiency and reduce risks. Trained engineer from Iraq, UAE, KSA, and North Africa. Active in student training and monitoring with SPE. His experience is in logging tool, cement evaluation, well integrity, reservoir testing. Completed more than 130 PLT job, 320 cement evaluation, 60 corrosion log. سيتم إرسال رابط الآراء في نهاية المحاضرة، ويرجى الالتزام بإغلاق الميكروفون. شكرا جزيلا لكم. أستاذ محمد، تقدر تتفضل.
شكرا جزيلا رضوان. السلام عليكم جميعا ومساء الخير. شكرا لحضوركم لهذه الفعالية من قبل مهندسين نفط البترول SPE. اليوم إن شاء الله راح يكون هو البارت الثاني من البرودكشن لوجينج tools. I will share my screen and just please let me know if you can see it.
تمام أستاذ، وضحت.
شكرا جزيلا. شكرا جزيلا جميعا للحضور. ان شاء الله اليوم راح نكمل البارت الثاني من البرودكشن لوجينج from the diagnostic to decision making with the tech log. ان شاء الله اليوم راح ناخذ الجانب العملي من البرودكشن لوجينج. So yesterday we have covered like the theoretical part for the production logging, that including the concepts, the principle of each modules and how it's working. Yesterday also we have covered the objective of the BLTs. What's the objectives of the BLT, the production, injection monitoring, also for the leak detection, diagnose the tool, well testing, all these, the application of having the BLT tool, the production logging in our wells. عرفنا كذلك شنو الchallenges بالproduction logging tools, what are the modules of the production logging tools, the spinners, the spinner size, the density, the pressure, the temperature. So today, we can imagine that we have run already the production logging tools, which is the BLT, inside our wells. And we also recorded some of the bases, recorded some of the data across our area of interest. So after completing the log in the rig, or if the job is rigless, we're going to receive the data as if we are imagining we are a petrophysics, we are production logging engineers. We're going to receive the data from the field engineer in the wireline, from the wireline, or from the another segments. You are going to receive this data from them, which we call it raw data. That means this raw data, it's not processed. So we're going to receive this data and we're going to work on it in a software in order to come up with a result, in order to convert this raw data into processed, interpreted data. So we're going to need this software. So today in this part, I'm going to introduce to you the SLB TechLog software. Using this software, there's a plugin called production logging that we can use it in order to process this data. So as I believe you have already heard about the TechLog. So this TechLog software, it's an SLB software or SLB platform. It's a complete platform that you can do the analysis, the processing for multiple domains. You can do it for petrophysics, rock analysis, geomechanics, reservoir, XPT, drilling, well bore, stability, geomechanics also, as well as one of them is going to be the production. So here the production is going to be the production logging. So there is a specific modules for the production logging. You can have it inside your TechLog. And this is the plugin and this is the modules as well and the features of the TechLog production logging. So you can do the complete workflow from starting from data uploading or importing till have the rate calculation, SIB as well, and the one which is very interested in this plugin, which is going to be well performance advisor that I'm going to talk about it in the next slide. So this is the production logging suite inside the TechLog, and this is the features of having this plugin inside your TechLog. So it can support like it can support any tools from another companies or the vendors. What I mean is يعني إنه حتى لو كانت الداتا إنه هي كانت إنه مو بس داتا SLB باعتبار السوفت وير هو SLB، بس كذلك ممكن إنه تسوي البروسيسنج اند انتربريتيشن من مختلف الشركات، من مختلف السيرفيس كومبانيز what we can do. فيسبورت all the tools مهما كان هي شنو نوع التول. بالاخير انه احنا if we have the sensors, if we have the tools measurement, we can always do the processing and interpretation using the TechLog software. So it's a complete workflow, and also it can integrate it with another domains. شو هنا شنو المقصود ب integrated with another domains؟ يعني مو ممكن انه تحصل مو بس بيانات البي ال تي، بس ممكن بيانات for example الOpenhole، reservoir, XBT, pressure points. You can always integrate all these data together in one layout and see the correlation، التطابق ما بين النتائج اللي راح ممكن نحصلها باستخدام البرودكشن logging tools. طبعا هذا هو راح يكون workflow. This is the workflow of having every BLT, starting from the data uploading or data importing. Then we're gonna set up. Here what means set up that I'm gonna also prepare the data, what we call data preparation. We're gonna, because you know in the BLT you're gonna have up passes and the down passes, and many it might be 3 passes or 4 passes or 6 passes, it depends. So you need here to prepare the data. That means prepare the data. You split the up passes from the down passes, and then you display the data. So now we import the data. خليناها بالsoftware. Now let's display it. We have to display it in order to QC it, quality control. So we need to make sure that our data is good enough to proceed with the next step, with the proceed to the next workflow. If the data is good, I have done with my QC. In my opinion, the QC is the most important part, because from the QC that you're gonna know qualitatively which I would say formation is producing, which formation it's having more contribution. This is all can be done qualitatively from a QC bar by just visualizing the data. Then if we are good to go, the data's quality is good, everything is good, we can move to the next, which is going to be the spinner calibration. So البارحة احنا حكينا على السبينر calibration، وقلنا احنا السبينر كاليبريشن اللي هو العمليه والورك فلو اللي انا استخدمها باستخدام سوفت وير على مود انه انا اي كونفرت، احول الروتيشن مالت السبينر الار بي اس into velocity. So this velocity it's gonna equivalent to the mixture velocity. So I'm gonna convert the RBS, the rotation، نحولها إلى velocity باستخدام خطوة السبينر calibration. بعد ذلك الداتا ستاكينج. داتا ستاكينج اللي هو بنقدر نقول عليها ببساطة إنه أنا أخذ معدل القراءات. لأن أنا عندي بالأخير راح تكون عندي 6 curves، إذا هي تكون 6 passes فراح تكون عندي 6 curves، يعني 6 readings of the pressure across the area of interest. فأنا راح أخذ معدل شنو معدل أو average of the pressure passes, average of the reading of the spinner, the velocity, average reading of the temperature, and so on. Okay. If there is like, this is an optional, that means correction, so we don't go deep with these corrections. But regarding to the workflow, data stacking, after you complete with the data stacking, you need, before you proceed with the final step, which is going to be the rate calculation, you need to identify what? You need to identify the fluid properties, the BVT, for example, the salinity of the water, the gas gravity, the oil gravity, and so on. So if you have done with your fluid properties, as well as from the data stacking, you can now do the rate calculation. So after doing the rate calculation, you have done with interpreting the data. يعني هنا بالاخير هنا بهاي الخطوه احنا ممكن حصلنا الريت كالكوليشن، معدل انتاج الماء، معدل انتاج النفط، ومعدل انتاج كذلك الغاز في حاله وجوده داخل الداون هول كونديشن or in the surface condition. فهنا هي توضح لنا الخطوات اللي ان شاء الله راح نشوفها بعد ذلك بالسوفت وير مباشره، اللي هنا داتا بريبريشن، اللي هنا راح ممكن انه اسوي بريبير للداتا، انه اي سبلت، انه اعزل طبق الاب باسز فروم ذا داون باسز اند سو اون. بعدين راح تكون بهذا الشكل، اذا هي كل الباسز راح تكون من اسوي لها داتا بريبريشن، فراح ممكن راح تطلع لي على شكل داون باسز على كتر، الاب باسز على حدا، وكذلك الاب باسز على حدا، على مود تكون سهوله للقراءه وسهوله التشيك الانفورميشن والكيو سي بارت. هذا يبين الفيديو الصغير، يبين شلون انا اسوي داتا بريبريشن، بس مجرد ضغطه زر واحده فهنا الداتا it will be انه نقول arranged by the direction of its up passes or the down passes. هنا عندنا اليوتيليتيز، مختلف اليوتيليتيز. انا ممكن انه I generate an image from the props، يعني تكون هنا سهولة انه القراءة بعد هنا، انه customizing نقدر نقول عليها، customize your layout, customize your visualization, all can be done in this step. بعد ذلك هنا البروسيسنج والستاكينج. هنا اهم بارت هو راح يكون عندنا هنا البارت مالت السبينر كاليبريشن، فهنا من خلالها انه انا احول الار بي اس into the velocity، hold up processing، multi sensor processing في حاله عندنا اني غير تول، اللي هي التول الثانيه اللي تكون بها مو سبينر وحده، بها تكون 5 spinners and we have discussed it yesterday regarding to the FSI. بعد ذلك you have to identify, as I mentioned, the PVT, the fluid properties, the fluid regarding to the salinity, the gas oil ratio, GORs, the API or the gas gravity of the oil and the gas, and so on, till you get the final data like this one. So this will be the final output. I'm going to tell you each perforation, which is this perforation or the formations, how much is it producing and what the type of the fluid and what direction of it. So you can see here from this data that this perforation, it's producing only water, and this confirmed by having the density, by having the water hold up, by having also the another measurements, and it's matching here. So you have at the end you're going to have two curves, one that is the modeled, one it's the measured, and it should be overlaying or close to each other, okay, in order to have a good, I would say, result for the rate calculations. While, you see this perforation, it's producing like a mix of oil and there is like some of the gas. And this gas, it might be liberated or it might be even free gas. And so on. So you're going to have a clear idea about every meters, okay, of these perforations. What's the type of the fluid and how much fluid is it producing or contributing and what the direction of it. And this is our main objective of having the BLT. So you're going to evaluate the downhole conditions and the production profile of your wells. بالنسبة لهذا السلايد راح يوضح اللي هي integration of the data. So you can integrate all the data. You have the SWIN data, you have the open hole data, you have some of the data from the BLT. You can integrate it all together and see the response. If this one is producing, for example, water, I need to check, for example, the saturation log and see the water saturation, the oil saturation. So you can have more clearer visualization and integration of the data using the TechLog software. اخر بارت راح يكون هنا موجود هو عندنا هو البارت مالت الول performance advisor. سو بعد ما كملنا انه طلعنا النتائج الاوليه من البي ال تي، فهنا الفكره من الورك شوب اللي احنا سويناها او this webinar from its name it was from diagnostic to decision making, right? So because the BLT, it helps us or it supports us in order to plan for the intervention, what we're going to do next for this well in order to optimize, sustain, or increase the production. So the first part now, we have already diagnosed what is really happening inside this, for example, let's say this well. So this well, the last formation, it's producing water and we don't know, and we don't want this. So after this one, and if you confirmed the water that we are producing from this well is coming from this perforation. So we can just plug it, okay? Isolate this formation from the rest of it. So we can just add a plug here, and we're gonna have only our desirable fluid, الفلويد اللي احنا نريده بالإنتاج وهو يكون المينيم. For example, for some cases, it's gonna be the oil, right? So in this case, you can plan for it. Yes, you can plan for it. So باستخدام نفس السوفت وير ونفس البلجن طلعت احنا النتائج الأولية. Let's imagine this is our preliminary results. احنا شفنا إنه the bottom perforation it's producing water, so we don't want this. So what you can do inside the software after you have done with the interpretation, you can plan what's going to be next. What is be the decision? What will be the intervention plan? You can propose it always. So the proposal for this case, it was the setting a plug at this depth, as you can see here, in order to just like plug this perforation because I don't want any water to produce from my wells, okay? So you're gonna plug it and you're gonna simulate, okay? What's gonna happen? My production is gonna be increased, how much is gonna be increased, if there will be any more water, and so on. So this one is going to help you also to simulate your interventions plan for if there is any after checking the data quality control and the interpretation of the BLT. Also, in terms of economics, it can also help you in the economic side and tell you how much this intervention plan is going to cost you and when you're going to compensate for this cost after producing from your wells. So this is more or less the technical parts in using the BLT data inside the software. But now this is just the slides, okay? So now let's move to the TechLog itself and see how we're gonna do all these steps in the TechLog. Okay, so can you see my screen of the TechLog, please?
نعم أستاذ واضح.
So I have the data in DLS file. So I'm just gonna drag and drop, for example, this data. I'm just gonna drag it and drop it here. This is the well name. I'm just gonna hear what يعني إنه إحنا نقول نرتب الداتا نخليها just like imagine you are إنه تجمع الكل اللي نقدر نقول إنه نجمع كل البيانات أو نجمع مثلا إذا كان عندك بيانات مهمة one folder. Here what we are call it is a grouping. So what I'm gonna do also I'm gonna put all these last files or all these passes in one folder. I'm gonna call it, for example, the flowing. The folder is now flowing now. Okay, so I'm just gonna now import the data by just clicking on here. remove it from here. I don't need it anymore. Now I'm going to have my flowing data here. So this is all the up and the down buses. So now in order to do the first step, you remember it was a data preparation. So now if I'm go to the PLC, production logging, this is all the features that I have. I'm going to go in sequence in order to reach to the rate calculation. But I don't need all of them. I just need maybe 3 of them. So I'm going to go with the data preparation. I'm going to go with prepare the data. So I'm going to ask you which group you're going to prepare. I'm going to tell him with this one. You have here 2 options, express and the custom, if you would like to intervene. I will go with the express. And now you see, you're going to check my data. It will be rearranged in another folders called buses. If I open the buses, there will be what? There will be up buses, the down buses, as well as my stations here. The station is, instead of the tool is moving up and down, the tool, they stop the tool at a certain depth and they record the data when the cable speed is 0. Okay, but the main buses is going to be the up buses and the down buses. These all the buses. So now after I have done with the data preparation, I have prepared my data. Okay, the next step is going to be what? The next step is going to be is visualize this data. I want to see this data. How good is it, right? So now I'm going to go to the next step of visualizing my data. This is the flowing. I'm going to tell you which direction you would like to display. I would like to display up buses, the down buses, and the stations. Then from here, I'm going to choose what the sensor I would like to display. For example, here the pressure, temperature, pressure. This is the density. I don't need all of this. This is the spinner. This is the cable speed. Yes. This is the caliber BFC1, BFC2, the gamma ray as well. So I will gonna display this basic sensor alone. Then I'm gonna display another layout, just QCing the probes, because I have 4 probes here for the water holdup, and I have another probes, 4 probes for the gas holdup. So I'm gonna display only these. If you go here to display option, you're gonna have like some here of the scale. What scale would you like to have this data? The temperature scale, the BFC1 scale, the BFC2 scale. For example, if I would like to change here, I will minimum for 2.5 to 4, 2. Okay. But you can always like also change it later on. So after you press this one, the data will be displayed for you. If you would like it without rates, you just go here. You know, you have all the data, all the passes, up and down passes in this layout. This is the gamma ray, as you can see here. This is the BFC1, the caliber first, that's first caliber, and the second caliber, because you have X and Y. And you're going to check the first part you're going to do, just check the data, all the passes are on depth, are all overlaying. Your caliber reading toward the expected ID for your casing or tubing. The next thing you're going to check if your case build speed is consistent. That means full straight line. So you see here, this pass is not really, it was consistent here, but here you have a kind of a drop in your cable velocity for this pass. And this is the spinner readings is going to be. This is the density, how much the density is it. And this is the pressure. This is also what this is going to be your temperature. Okay, guys. Okay, so just let me, so I can make it clear for you. I will just reshare my screen. Okay. So now, after I have displayed all my data, so I'm going to import. Okay, I'm going to display my perforation. I have already the perforation in my tech. I'm just going to display it. So this is my perforations. So it's telling me just qualitatively, okay, just by checking this data, okay, without doing anything, with just visualizing. So you can have a clear idea what's really happening inside your well, okay. So you see, this is the first perforation here. This is the second, and this is the third one. If I'm going to check here, the bottom perforation, below the bottom perforations, the density, it was reading 1 point something, 1.1 something. So that means it's a completely water. We know it's a completely water, right? While the spinner is telling me it's nothing, like it's a full straight line and it's reading very low. Okay, even the positive of them is reading positive, the minus of them or reading minus, and between zero baseline. So I know there is no flow here, and the fluid is a water. From density, it's also going to tell me if there is any indications of having any entry. Why the density is telling me nothing. The fluid or the first entry, it was coming from just here, right? So you see the deflection in the here, in the deflection here in the spinner. That means there is a fluid entry is coming from this perforation, as well as this, what the density is telling me. Okay, I have a drop from water 1.1 till around 0.4 something. So this is for sure a hydrocarbon and very light hydrocarbon. The temperature is also correlating, telling me there is a deflection and the cooling effect. Okay, so you see here this cooling effect. That means I have a clear entry from this area. So this is the first fluid entry that's coming from here, and this is the second one, and this is the third one. While above it's showing a complete straight line, that means there is no fluid entry, and the last entry, it was coming from just this part. Okay. بعد ذلك هسه هنا عندنا حاليا الداتا كلها موجوده. شيكت انا السبينر. I have checked the spinner. The spinner is good. Reading consistent, indicating our entries is coming from here, and all the perforation are contributing to the production. But how much? We cannot know it by just visualizing the data. We need to do further work. So the further work, before do the next step, so you remember that we had also another measurements. So just let me save this one. We can always save it from here. Call it, for example, basic sensors. Then what you can do also, you can check all your props. You remember yesterday we have talked about the props, the E props and the O props. This is the O props here. And this is the E props, the water holdup and the gas holdup. So we can have a clear idea if we have a gas, if you have a water, and the combination of them. So you see, this is the gonna be the gas holdup from here, and this is the water holdup there. So from the water holdup here, if I import my perforations, so you see below the perforation, it was showing a completely water. The water holdup was reading 1, that means 100% is water. While the gas holdup, that as you remember yesterday, we were discussing about the gas holdup is differentiate between gas and liquid. So it's telling us there is no gas at all. That means it's completely liquid, and this liquid is be 100% the water. بعد ذلك من دخلنا بالبرفوريشن الأول برفوريشن قاعد نشوف لاحظ هنا حاليا دخل عندنا الهيدروكربون from the water holdup, and this hydrocarbon, as you clearly seeing from the ghost, it's a gas. So we have totally checked the data. Now we have a clear idea what the fluid we are producing from these wells, and this is showing the hydrocarbon, the gas, and from the props itself, it's reading, it's a combination between the water and the gas. بعد ذلك أنا شيكت الداتا كلها مالتي. نروح نرجع لأول لاي اوت اللي احنا سويناها وحفظناها. النكست ستيب مثل ما نتذكر بالسلايدز موجودة، هي كانت إنه سوينا داتا فيجواليزيشن. بعد ذلك راح تكون بعد الداتا فيجواليزيشن راح تكون هو السبينر كاليبريشن. السبينر كاليبريشن هنا من خلالها راح I will convert my RPS into a velocity. So before I convert it, I need something to do. I need to take a calibration zone. That calibration zone, I will calibrate all the passes across these depths. So I need to insert another zones which called the calibration zone. So I will calibrate the tool here. I will calibrate another depth is here between the perforations and there. So I can come up with what, guys, with the total velocity or the mixture velocity. With what you need to do is just go to the spinner velocity, and import your spinner. You need the spinner readings as well as the cable speed. Then you go back to the workflow manager. You just drag and drop all the up and the down passes. Go to the zonation. You insert the calibration zone that you have picked here in this. We're going to insert it here from this option, and you're going to go just with display. So after displaying, you're going to have this cross plot that we discussed yesterday, that you need to have all the points are fitting the slope of the line, and this is the zero flow, and this is going to be my this is going to be my fluid velocity profile. So this is the velocity, and previously we had only the rotation per second or rotation per minute. We had the rotation. We convert this rotation in this velocity profile, and this is what we really need. So I'm just going to save it here. We save now. We have a velocity for each pass. So the next step is going to be what? The next step is going to be identifying the fluid properties. So now I have the velocity profile. I have checked the data. I have everything. The next steps is going to be identifying the fluid properties and also the data stacking. I'm going to take an average reading of all these passes because I need to just end up I do one curve to match it in the rate calculation. So you see here, this how many readings? This is 6 readings. So what I'm going to do, I'm going to take an average of all these passes, or depend which pass that you're going to really choose. We can go just to data stacking. We're going to go to the data stacking. After we go into the data stacking, I'm going to go and upload all the data. Go to the main. There is here a template that we can choose what the sensor that you really identify. So you remember yesterday what we had in the slides? You need some of the sensor in order to do the rate calculations, right? As per this equation, you need the velocity and you need the area. So the area, that's mean you need what? You need the caliber. The velocity, since we have here 2 faces, you need the velocity of the oil and the velocity of velocity of the gas and the velocity of the water. So that means you need also to identify the holdups for each face. بعد ذلك انه انا راح اختار هنا شنو السنسورز اللي انا اريدها. اريد الكاليبر، اريد الواتر هولد اب. For example, gamma ray, I don't need it. The caliber, this one, I don't need it because I'm gonna take the average caliber. بعد ذلك ممكن ناخذ الجاز هولد اب، الapparent velocity for sure، ناخذ velocity اللي we calculated in previous step, density, pressure, and the temperature. بعد ذلك هنا ممكن انه باعتبار انه عندنا 6 passes، بهاي الخطوه انه ممكن ان تختار انه يا passes في حاله one of the pass it's not really in a good data quality, you can always disallow. You tell the software I don't need this pass anymore. For example, the caliber, it has 6 passes here. It's always recommended to go with the up passes. So if you don't want the down passes to be included, just insert here 0, and it will be disallowed from the average. So it's going to be take out of 6, only 3 passes as an average. So if you're done with this step, you're just going to go display the data. And this is how it will be look like the data stacking. So you see here the black curve. This is the average of all the passes. This is the average of all the caliber. This is the average of all the water hold up, average of all these 6 passes, okay? So if I'm done with this one, it will be creating me a new data set called data stack that has only these black curves that I needed in order to do the rate calculation. Okay, so now I have done with the data stacking. The next 2 steps, okay, before the final step, which is the rate calculation, I need to identify my fluid properties, right? I need to tell the software the BVT of these fluids. So I'm gonna go here, the fluid properties, go back to the workflow manager. I'm going to use my final data set. This data set, I don't need it anymore. This will be my final data, the summarized data, I would say. So I'm just going to drag it and drop it here. I'm going to go to the main. I'm telling the software what the fluid I have. I have water and the hydrocarbon. But here it's asking also me what kind of the hydrocarbon. I'm going to tell him it's a dry gas because I know this well, it's a producing gas. So the salinity, I have it, that's been provided by the client. And this is the gas gravity that also been provided. I'm just going to go now and save. We're done. خلاص. The next step, it will be just the final step and I'm going to show you the complete results, how much each one is producing. Okay. So this is our data, right? This is the final data, which is the black curves, and we have identifying our fluid properties. Here, there's another thing called the fluid properties. So now we need to go to the rate calculations. Okay. The rate calculation, that means I'm going to give all the inputs to the software. I'm going to tell him the density, how much is going to be the holdup of the oil, of the gas, and also the holdup of the water. I'm going to tell him the velocity profile, how much the velocity is reading, the area. So just going to do kind of the matching and using some of the correlations in order to compute for me how much each perforation is producing. So you remember at the first we had how many perforations? We had the 3 perforations, right? So this is 3 perforation, each one it has a different thickness, right? So this one is from this depth to this depth, and this one from this depth to this depth, okay? But what I would like to have a very detailed, I would say, computation. I want to know each part of this perforation, how much is it producing? So I'm gonna now create what we call it an inflow zone. An inflows or contributing zone, okay? So what I'm gonna do, I'm gonna insert a new zonation and just matching with my perforation. Instead of having one perforation, I'm gonna just create a zone across which area that is being producing. For example, from here to here, this is 100% sure it's producing. From here, it's a kind of a straight line, so there might be nothing. So I'm gonna check, okay, I have also here, right? So this is all that this will be my, for example, my inflow zone across this one. Here I can just use one maybe, an inflow zone, or I just cut it like this one, because this one there is another range of a contribution it might be. While the above no, it can be like maybe 3, 4, it's all depends on the user or the interpreter. He can do it 2, he can do it 3, it doesn't matter. Then I'm just gonna now save it and I will call it an inflow zone. Okay, so now I have created my inflow zone. I know where exactly the fluid is coming. Not necessarily is coming across all the perforation. It might be only coming from the top part, from the bottom part. So I need to be very precise, okay, and accurate in my interpretation. So the final step is going to be now the rate calculation. The rate calculation, I'm going to tell the software this is the temperature, my pressure, my caliber. So if I go to my stock data here, I have used the caliber average. So I'm going to tell this is my caliber. This is my, for example, the density. This is my apparent velocity, the density, water holdup, and the gas holdup. So here, since we have water holdup, we have a gas holdup, and we have a density as well. So you know how many fluids that we have inside the well? We have mainly, I would say, gas and the water, right? So in case if you have multi-phase, you need at least 2, I would say, sensors to identify the holdup of the water and the holdup of the another fluid, or the holdup of each phase. So you need at least the density and another fluids, or you are very accurate with your PVT data, because the software is going to use the PVT data and compare it with the measurement in order to compute the holdup for you. But in case here we have the water holdups and the gas holdups, okay? So I'm gonna, what here for this case, I'm gonna rely more on these holdups instead of having the density. If you would like to go very accurate and you are very sure with your, I would say, PVT, you can always have the density and go with all of them, okay? For this case, I will just go with the water and the gas holdup, and we can try it later with the density if we have more time. So I'm going to now go now it's going to be showing me this, I would say, window. I'm just going to drag and drop the data set here. So this is the pressure, temperature, all the sensors that I have chosen. Now, if I go to the general, so it's asking me here, يسألني على BVT. So this is the BVT, the flow zonation. So you remember the zonation, the inflow zone. So here we call it an inflow zone. This one. Okay. The rest you can keep it as automatic, or you can always, like I would say, customize the contribution zones, create another contribution zones. But for this, let's go with this one. It should be more than enough. Then if you're done with everything, okay, you just need to go and press the final one as a run. It's going to just take a few moments in order to calculate everything for you for the rates and for each phase. So this will be my final, I would say, output. This is my fluid profile. I have mainly gas. I have a water producing from some of the perforations, but it was mainly gas. But how much exactly? It will be also populated here in this window. It's going to be telling you each inflow zones that we have created, how much water is producing, how much is oil, how much is gas. And then going to tell you in the downhole condition, and as well as in the surface conditions. So this is the final step. This is what we reached to the end of the BLT interpretations. But if you would like to do in some of the intervention plans, you can always do it from the well performance advisor, adding a new perforation, close this perforation, and so on from the interventions workflow that you can apply for this BLT data. So this is, I would say, the final workflow. This is the final step of the BLT interpretation, is to compute the rate of each phase, how much each inflow or each perforation is producing or is contributing to your protection. And how you are going to be sure your data or your interpretation is accurate. These two curves, the modeled and the measured, they need to be overlaying on each other. That means you are very precise in your interpretation. Not only for the velocity, but also for another, I would say, sensor that you're going to compute the holdups from them. Okay, so this is the end, I would say, of the technical part using the software. This is the part that you can reach to the, I would say, final step to make the decision or the plan for the next step. If you are the operator or if you are the service company, you can handle it to your client in order to move on with the next operation if they are planning for any interventions. Okay, so guys, if you have any question, إذا عندكم أي سؤال حاليا عندنا بعد مجال. إذا عندكم أي ورك فلو في حالة إنه ما فهمتوا ممكن نعيده خلال هاي ال10 دقائق إنه we can recompute.